feeling good. It's an especially good day today because we are going to be having a little go at a fig roll, which is, I think, one of the most neglected biscuits of all time. I probably went a couple of decades myself without eating a fig roll, and I don't know why, but more of that later. Today's a sad day because it's the last day we're going to be doing integration for a while. So don't worry though, there will be a homework with a bit more of old mixed exercise 13 for you to get your teeth into. And what we're going to be looking at today is the area between curves and other straight lines. So it gets a little bit tricky, but if you've handled what we've done up till now, should be no trouble. Right, so while I tuck into my fig roll and get ready to give you a proper idea of it, copy down this question, and you may want to pause the video and see how far you could get with working it out for yourself. We want to know the grey shaded area here between the line y equals x 4 minus x, that curve there, and y equals x. Well, there's so much more substance to a fig roll than you expect, and you have the knowledge that it's doing good for your system too, keeps you regular. Right, anyway, moving on. If I were to drop a line from there down to there, and I worked out this triangle, I could take the area of that triangle away from the integrated thing to find out the area of the whole thing under the curve between that and the x-axis, between this point here and there. So the first thing I need to know is, what is that? Looks like it's about 3. Is it? Well, we need to do simultaneous equations with these two, or just say, well, y is going to be equal to that and that at the same time. So all we need to say is x 4 minus x is going to equal x. So if I expand the bracket, that gives me 4x minus x squared is equal to x. Take the x across to the other side and we get 3x minus x squared is equal to 0. Now if I were to factorize that, I would get x outside 3 minus x is equal to 0. So the two roots are going to be x equals 0, which is what we've got there. So that's one place where they cross, and the other place they cross when this bracket here is worth 0, which is when x is 3, because 3 take 3 is 0. Therefore that value there is 3. And what we're looking to do is, if I expand, I'm going to be first of all integrating between 3 and 0 for 4x minus x squared, and then from that I'm going to be taking away that area there. I could just do that area quickly, couldn't I? So if I call that area b that we're going to take away, b is going to equal, well, you're going along 3 there and you're going up 3 because it's the line y equals x, isn't it? So that's going to be 3 times 3 over 2, isn't it? Which is 9 over 2, or 4.5. So we'll just call that 9 over 2 for now. And then we'll be taking that away from what we get here, won't we? Right, so that means we can get our square bracket out. We now need to integrate this. My x value goes up to 2. I divide the 4 by the 2, which gives me 2. And then here my x value goes up to 3. I divide by the 3, which I can just write like that. And that's going to be between 3 and 0. Now, as we've got no constants in here, we know the 0 bit's going to be 0. So I just need to do 2 times 3 squared is 2 times 9 minus 3 to the power 3 is 27 divided by 3 is going to be 9, and we know we're going to be taking 0 from that, so that's going to give me 18 minus 9, which is 9. So 9 would be for the whole area under the curve, and then we need to take b, which is 9 over 2, which is half of 9. So our answer is 9 over 2, or 4.5 square units. Our final integration example then, and this one I do want to talk through reasonably slowly because it's got some trickiness about it that made me think more a little bit, I can tell you. So the thing is, we want to know this area here, and if I integrate between this point here and 0 for x, I can't do that because it's going to give me this area here as a positive. This area here is a negative. When it adds those together, you actually end up with less than just this one on its own. So what we have to do is we have to integrate just for this area here, which will end up adding that bit back in for us, which is a bit of a strange thing to think about. But do not worry, I'll talk you through it slowly and I'm sure we'll be fine. But you may want to go through this a few times before you've got it, and you may want to ask me a question or two personally as well. First things we need to work out are, what are these values a and b? Well, this is going to be one of the two roots of x minus 3, isn't it? Which we know one of the roots is going to be 0, which is just there, and the other root is going to be 3, because 3 take 3 equal to 0. So we know that a equals 3, and then we need to work out what b is, which means we're going to have this equaling that, aren't we? So we've got our x minus 3 is going to be equal to 2x. Expand the bracket to get x squared minus 3x equals 2x. Then take that across would give us x squared minus 5x equals 0. Factorize would give us x minus 5 equals 0. Therefore x is equal to 5 to make the bracket 0 there. So that means we know that b is equal to 5. Now we need to work out this area here. So this is the area under the curve between 5 and 3, and then take it away from the whole triangle. If we do the triangle first, pause the video, do that nice and quickly. We're going along 5, and then we just need to know how far up we're going, don't we? So in order to know how far up we've gone, we need to substitute x is 5 back into this equation, don't we? So y is going to equal to 5 times 5 minus 3. 5 times 2 is 10. So we know that that value up there is 10. So we've got a triangle that is 5 base times 10 height divided by 2 gives us 25 square units for the triangle, and then we're going to be taking away from 25 what we get there. So we are integrating between 5 and 3, and what we're going to be integrating is, if I just expand that now, x squared take 3x dx, and that is going to be equal to, get a nice square bracket out, let's integrate that now. So the x value goes up 1 to 3, divide by that 3, the other x value goes up to 2, and we divide by that 2, and we're doing that between 5 and 3. So that's going to give us 2 things to do. So we've got the 5 one and the 3. Have a little go at that, pause the video, make sure you've got that okay. That should have given us 125 over 3 minus, that's going to be 25 times 3 is 75 over 2. and just here we have 27 over 3, which is 9, and 3 squared times 3, so that's 9 times 3 is 27 over 2. Sort out those fractions, gives us 25 over 6 for this one, and for the other it's giving us negative 27 over 6, which we can then add together. Adding that to that does give you 26 over 3. So the shaded region is going to be the 25 that we had for the triangle minus that 26 over 3, which is 49 over 3. And you can turn that into a mixed number if you like, and that's your final answer. Right, now I am expecting to get maybe quite a few calls of people saying, oh, I'm not sure how to do this, but I'd like you to have a go at exercise 13G, pages 304 to 306, questions 1, 3, 4, 6, 7, 8 and 11 should give you a nice variety of the sorts of things that go on. You are going to need to think a little bit around the box and use your use your initiative at times, but don't worry if you get stuck. I'm always here to help you. Okay, and that should be integration for us done. We will be on to logarithms next time. Exciting stuff, folks. Goodbye.